Good morning everyone. I hope all of you are well. Today we are going to start our new topics which are based on the packaging of the solids, which are categorized into three: one dimension, two dimension and the three dimension. I hope you already completed last two lectures which were based on the type of solids. We categorize type of solids into two categories. First one is the amorphous solid and the second one is the crystalline solid. And we further moved on the types of number of particles in a unit cell and the types of unit cell. The types of unit cell we already discussed. What are the types of unit cell? Number one, simple cubic unit cell known as primitive unit cell. Number two, body centered unit cell. Number three, face centered unit cell, and the number fourth is end centered unit cell. And as well as we already calculated the number of particles in different type of unit cells. We call them as a rank of the unit cells. So our new topic for today, that is the packaging of the solids. Close packing in one dimension. There is only one way of arranging sphere in one dimensional close packed structure. That is to arrange them in a row and touching each other. In this arrangement, each sphere is in contact with two of its neighbors. The number of nearest neighbors of a particle is called its coordination number. Thus, in one-dimensional close pack arrangement, the close packing and the coordination number is 2. Close packing in two dimension. The two-dimensional close pack structures can be generated by stocking place the rows of close pack structures. This can be done in different two ways. First, the second row may be placed in contact with the first row such that the sphere of the second row are exactly above those of the first row. The sphere of the two rows are aligned horizontally as well as vertically. If we call the first row as A type, the second row being exactly the same as the first type, so is also of A type. Similarly, we may place more rows to obtain AA type of arrangement as shown here. In this arrangement, each sphere is in contact with four of its neighbors. Thus, the three-dimensional coordination number is 4. If the center of these four immediate neighboring spheres are joined, a square is formed. Hence, this packing is called square close packing in two dimension. Now, next is hexagonal close packing. In hexagonal close packing, the second row may be placed over the first one in a staggered manner, such that its sphere fit in the depression of the first row. If the arrangement of the sphere in the first row is called A type, the one in the second row is different and may be called B type. When the third row is placed adjacent to the second in staggered manner, its sphere are aligned with those of the first layer. Hence, this layer is also of A type. The sphere of similarly placed fourth row will be aligned with those of the second row, that is B type. Hence, this arrangement of AB type. In this arrangement, there is less free space and this packaging is more efficient than the square close packing. Each sphere is in contact with 6 of its neighbors and the two-dimensional coordination number is 6. The center of these 6 spheres are at the corner of a regular hexagon. Hence, this packing is called two-dimensional hexagonal close packing. In short, that is HCP. As you shown in this figure, in this layer there are some voids which are known as empty space. These are triangular in shapes. The triangular voids are of two different types. In one row, the apex of the triangle are pointing upwards and in the next layer downward. Packing in three dimension. All real structures are three-dimensional structures. They can be obtained by stacking two-dimensional layers one above the other. In the last section, we discussed close packing in two dimensions, which can be of two types, square close packed and hexagonal close packed. Let us what type of three-dimensional close packing can be obtained from this. Three-dimensional close packing from two-dimensional close packed layer. While placing the second layer, close packed followed one row was placed adjacent to the other. The second layer is just placed over the first layer, such that the sphere of the upper layer are exactly above those of the first layer. In this arrangement, sphere of both the layers are perfectly aligned horizontally as well as vertically, as shown here. Similarly, we may place more layer one above the other. If the arrangement of the sphere in the first layer is called A-type, all the layers have the same arrangement. Thus, this lattice has AAA type pattern. The lattice thus generated is the simple cubic lattice and its unit shell is primitive cubic unit shell. Now second is three-dimensional close packing from two-dimensional hexagonal close packed layer. Three-dimensional close packed structure can be generated by placing layer one over the other. Number 1. Placing second layer over the first layer. Let us take an example of two-dimensional hexagonal close packed layer A and place a similar layer above it, such the sphere of the second layer are placed in the depression of the first layer. Since the sphere of the two layers are aligned differently, let us call as the second layer as B. It can be observed here that not all the triangular voids of the first layer are covered by the sphere of the second layer. This gives rise to different arrangement. Whenever a sphere of the second layer is above the void of the first layer, a tetrahedral void is formed. These voids are called tetrahedral voids because a tetrahedron is formed when the center of these four spheres are joined. They have been marked as capital T. One such voids are shown here. At other place, the triangular voids in the second layer are above the triangular voids in the first layer. And the triangular, let's start with the voids, which are the empty space present in cubic structures. Voids are categorized into two types, tetrahedron voids and the octahedron voids. Octahedron voids are represented by capital T and octahedron voids are represented by capital O. Now let's study tetrahedral voids. Tetrahedral voids is formed by fourth sphere. Here the void of one layer are covered by the sphere of the next adjacent layer. Hence are called tetrahedral voids. In this efficient hexagonal close packing, the unoccupied space are enclosed by three spheres touching each other and lying in the same plane. Is equatorial triangle in shape. Therefore, such vacant spaces are termed as triangular voids or trigonal voids. Octagonal voids are formed by six spheres. When the voids of two adjacent layers overlap, they are called octahedral voids, as shown here. An octahedron is formed in three-dimensional structure. And again, you see in here, an octahedron is forming in three-dimensional structure. Voids, in case we need to calculate the number of tetrahedral and octahedral voids in a crystal structure. structure, then just knowing the number of sphere will serve the purpose. Suppose there are n sphere in the crystal structure, then the number of octahedral voids generated equal to n. The number of tetrahedral voids generated equal to 2n. Now let's start with placing third layer over the second layer. When the third layer is placed over the second layer, there are two possibilities. Number 1, covering tetrahedral voids. Number 2, covering octahedral voids. Now start with covering tetrahedral voids. Tetrahedral voids of the second layer may be covered by the sphere of the third layer. In this case, the sphere of the third layer are exactly aligned with those of the first layer. Thus, the pattern of sphere is repeated in alternate layers. This pattern of sphere is repeated again and is also written as ABAB type pattern. This structure is called hexagonal close-packed structure. Each sphere is in contact with 12 other spheres. So the coordination number is 12 here. By covering octahedral voids, the third layer may be placed above the second layer in a manner such that its sphere cover the octahedral voids. When placed in this manner, the sphere of the third layer are not aligned with those of either the first or the second layer. This arrangement is called ABC ABC type. Only fourth layer is placed if sphere are aligned with those of the first layer. This pattern of layer is often written as ABC 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 type. This structure is called cubic close back or face centered cubic structures. Few metal, copper and silver crystallizes in these structures. Each sphere is in contact with the 12 other spheres. Hello students, I hope you understand the video. I make this video to understand in a quick manner and to understand in an easy way because everything here is going in a three-dimension thing. So I hope you like it and you understand the concept of packaging in solid structure in one dimension, in two dimension and in three dimension.